this video we're going to discuss CRA models for decimal multiplication algorithms. So we're going to look at two. The first one I'm going to show is actually converting this decimal multiplication problem to a fraction multiplication problem. And we'll kind of use that with our model to explain the standard algorithm for multiplying decimals. Okay, so just our model at the start, just to kind of show that this is equal to 65 hundredths. Right. We're working off the assumption that this is equal to 1, this entire square is equal to 1. So you can see this model has a width of 1 and then 3/10. So the width is 1 3/10, and then the height is just 5/10. Okay. So when we're looking at our model, right, this is just an area model, so we can see in here that, right, so this is, right, our 5/10 is the size of each group, so that's the columns, right, and then we have 1 and 3/10 of that group size of 5/10. Okay. So here we can see we have 5/10 right here. We could take, right, 10 of these, and that could be restructured as a tenth, and then we have these 5/100ths left over. So there, just in the area model, we can see that we do have the 6/10 and the 5/100ths. Okay. We'll look at the first algorithm is actually going to be converting this to a fraction multiplication problem. Okay. So instead of thinking of this as 1 and 3/10 in decimal format, right, we can also think of this as, right, 13/10, right? That's the same thing as 1 and 3/10. Okay. Multiply that by 5/10. Okay, and again, if we're thinking of our value of 1, right, this is our whole, right? So if this has a length of 1, we can see this has a length of 1 and 3/10, or 13/10, right? That's our fraction. And then same here. If we think of that in terms of fractions, right, this is 5 of the 10 equal parts right there, so that's 5/10. Okay, so when we're multiplying these fractions, again, it's that multiply across algorithm, so we're going to multiply the 13 and the 5, multiply the 10 and the 10. Alright, so we get 13 times 5, and again, that'll be 65. And then 10 times 10 will be 100. Okay, so 65 hundredths. Okay, so that's one algorithm that we can use, since students will learn this fraction algorithm prior to needing to learn the standard algorithm for decimals. This will be one strategy to use. Our standard algorithm for multiplying fractions. First, we're gonna look at how many digits we have to the right of the decimal point in our multiplier. So we have 2 here. Okay, so we're going to kind of keep that for later, but we need to know that we have 2 digits to the right of the decimal point. Okay. And then actually our algorithm for multiplying decimals is we're going to multiply these digits together as if there were no decimal points. Okay. So we'll set this up as 13 times 5. So we do 5 times 3. That'll be 15, and then so we have that 110 that we'll have to add on later, and then 5 times the 110 will be 5/10s, and we'll add on this 110 from earlier, so we get a total of 65 tens. Okay. So this product is 65, and again, since we had two digits to the right of the decimal point in our multipliers, that means we need to have 2 digits to the right of our decimal point in our product. So then, right, kind of how this shows right now, there's an invisible decimal point right there that we're not necessarily writing. So we'll move this, right, 2 places to the left because we need to have 2 digits to the right of our decimal point in our product. Okay. So kind of why that is, actually this fraction algorithm helps to explain that a little bit too. So we can see, right, if we write this as a fraction, right, 13/10 over 5/10, when we take a tenth of a tenth, that will always give us hundredths. So hundredths is going to be our new unit. Okay. Because previously, right, if we had 1 and 3/10 times 1, right, these would have had originally been I'm just going to show, but this entire model would have had a height of 1, so these stacks on the right would have originally looked like this, right? But if we want to just, if we have 5 tenths instead of 1 whole unit, right, we need to break this into 10 equal parts, so we'd be breaking the tenth into hundredths. So no matter what, our label or our denominator is always going to be hundredths. Okay? So the same would apply. This is kind of an easier example since it's just tenths. The same would apply for any number of digits to the right of our decimal point. Okay. So concrete model to kind of help visualize this can be the base 10 blocks. I didn't do the representational model. That could just be drawings, whether that's a set model or length model or an area model, kind of using those base 10 units as a reference point. And then again, our abstract model, this would be kind of our work for using that algorithm of changing the decimal multiplication problem into a fraction multiplication problem. So we just use that standard algorithm for fraction multiplication. And then again, this is that standard algorithm for multiplying decimals. So we treat this as a whole number multiplication problem. Count the number of digits to the right of the decimal point and our multipliers, and that is how many, the sum of that is how many digits should be to the right of the decimal point in our product.